Welcome back. This is Dr. Mantesh. We would like to continue with the next tutorial, that is the 6th B, in which we are trying to do a 2-input NAND gate with the drive of 40 by 20. Though it looks similar to the previous inverter, it's a bit complicated. Let's go ahead and do. So what we did in the previous tutorial, that is 6th experiment number 6A, we did this. Now we are supposed to increase this drive. Anyway, I am not going to do it now for 40 times. I already told why it is 2, 2 and 2 and 2. So this is because of this calculations that I have shown, that you already completed in the theory part. Let's go ahead and do a layout for this. This is an empty schematic from Microwind. Take a palette. So before that, I think you should select the foundry. Ensure that you fixed the foundry, one foundry. I am taking 120 nanometer. Now I am trying to generate a device for PMOS. The minimum is 0.6, that is 2, as you already know. Now we are trying to make it 40 times. That means 0.6 into 40. So it is somewhere around 2.4. micron. Now if I try to, as they mentioned clearly in the, so they are trying to say the optimal layout method. So if I simply do it in one finger, you can able to see, okay, I think I made a mistake. I can take calculator. Uh, 40 times 0.6 is 24 micron, sorry. Okay, it is not 2.4, it's 24 micron that we have to take. If I take a single finger, it will be too big. Can you see? It's very big transistor in one direction, which is not suitable and not an optimal method to do it. So what I do, I should delete it and generate with a finger of say, let's say 10 fingers. Okay, and click it here. Now the length is less and width is more. I can make it more by making it 20, so I can make it in smaller. So it's about area, and this has the same drive capacity. This has same drive capacity as that of the previous one. So we have say 10 transistors, and they are doing the same job of one transistor. Let's go ahead and do one more thing, that is we have to take NMOS, which is of 20, drive strength of 20 times the minimum. Minimum is 0.6, 0.6. Now instead of 40, we have to make it 26, that means it's 12 micron. Generate device, go down and keep it somewhere here, and we have to adjust this to, okay, so I have to bring this very close to this one so that I can. This is about taking 2 transistors. Now we have 4 transistors. So what I do, I'll just copy and paste it a couple of times. Okay, this is copy. So what I'm trying to do is trying to keep this very close to this. So this take, I think I did correctly. So let's check if something wrong. Nothing to worry. Okay, I think I made a slight bit of there's a gap here. Nothing to worry. Let's go ahead and just check. We are all in the learning phase. What will happen? Okay, similar to that, I have to copy and paste this as well, and I'm trying to paste it very close to this one. So let's copy this as well, and then this time I'm trying to put it here. Check for DRC all the time. This is good if you keep doing DRC. I'm trying to move this very close to the other one. Do the DRC again. If any errors, we should be able to do it in the initial phase itself. Let's go ahead and do connections. So now this is whole complete one transistor, one terminal is equivalent to these 5 terminals, 1, 2, 3, 4, 5, 6 terminals. Okay. So what I do now, these two are PMOS transistor. Can I move this up a bit? I am thinking of it. I don't know whether it is very difficult because it's too huge and the software is too primitive. So as I already told, I'm trying to move it. Bit upside. Yeah, I think it's very difficult because only the contacts are moved and nothing else. So what I do, I'll do just undo. I think undo did not happen. This is the issue with this software, as I already told. Let's go ahead and delete and do it clearly. Let's check DRC. Yeah, something is left here. DRC. Click all. Trying to copy. A bit of a gap here still persists. I'm trying to move it now because if I say DRC now, it will give you an error showing there's a slight gap here. So what I do, I'll try to move this, put it very close. Even if you keep separately, nothing wrong. Okay, I think still there is a gap exists. Yes. So I have to move it further. Even if you keep separately, as I am repeating these words, even if you keep separately and treat these as a separate transistor, nothing wrong in it. And check for DRC. no DRCs now, but I'm sure that there's still an alignment issue. Okay, no problem. Let's continue. Right. If I try to just move these things, it will be difficult. So let's do the connection. Go ahead and take metal. I'm trying to connect these two transistors. This is now drain of the transistor. Sorry, source of the transistor. This is PMOS. We'll take and zoom a bit. Go down. Sorry about that. What I'm trying to do is trying to connect these two. Metal one. This must be selected. Okay. Check for DRC. Okay, no violations. Do the same thing with this. Now I'm trying to stretch it simply. Okay. Stretch these things. Okay, escape. Stretch. Connect. DRC again. No issues. Connect VDD. I am trying to do similar to this, so I have connected this source and source, connected it to VDD, and now I am trying to connect this drain and drain, giving it to output, and all inputs must be shorted. All inputs of A and all inputs of B transistor must be shorted. Okay. So what can be done? View all and then go ahead and zoom it wherever you are trying to do it. So VDD I have connected. One more VDD I should connect it to N well. You can keep couple of them if you have doubt. VDD N well. Now they are common. Even if you don't keep, still it should work. And click all and zoom wherever you want to do now. I'm trying to connect these two. Okay. Now this is source of 1. Also check for DRC. If anything wrong, we should do it again. See, this may pose warning or error. Let's do DRC. Yeah, this is an issue now. Now what I should do, I have to move this bit here, stretch it, and do DRC now. Yeah, solved. And this is one transistor, my dear friends. You should connect it as a common, not metal, it is polysilicon. This is polysilicon. Till this point, it is single transistor. 1, 2, 3, 4, 5, 6. So this one as well. So I have to stretch it. Okay, I think I have to lay down. So now I am making some mistakes. We'll get a DRC error because it is too small. I have to stretch for one more lambda. Okay, it's not taking it. Stretch. So it's taking the other one, stretch. Okay. Now there should not be any DRC error, but there is a violation still here because it is lined separately. So I should stretch it separately. Okay, DRC. Now there are no errors. View all. So similar to that, I have to connect these inputs as well. Polysilicon. I want these all inputs to be connected. DRC. I think it's a bit of extra material that I put. I can put it back. I can reduce it, nothing wrong in it. So, and also these inputs are common. So I'm trying to make a input common to this as well and connect it to this. Fine. Now A is connected to A, B is connected to B. Do this for this as well. These are not so great things, but we are doing it just for study purpose. Do DRCs. So now A is connected to A, B is connected to B. Just now what I did is these connections. These A is connected to A, B is connected to B. So the remaining thing is this and this. Okay, let's go ahead and do. Similar to that, what we did in the previous, we have to take metal and connect and make a contact here. So we are ready with drain of NMOS transistor 1. Let's do DRC. Yeah, there is an issue. I have to stretch this a bit upside. DRC, no issues now. And I have to do the same thing with this as well. Take a metal and do these connections. Okay, this is ready. Just check DRC. No issues. Go down and do the same thing for metal 1. Connect it. So what I do, I'll consider this transistor as this one. So I can connect it to ground. Take ground and connect it here. And the other terminal of this transistor where I'm trying to connect it. What can be done? I think I didn't do it. These things can be connected together because they are in series, and this terminal would have been ground. At this point I don't want to go back because of shortage of time. I am doing it quickly. Now if I consider this as output, so these two are output, so what I do, I'll simply connect metal. So output is ready and visible node. What is not ready is connection between this and this. That means this terminal is nowhere connected. So what I should do, I should connect it to the, it's not a good idea, but it's okay. It's not so efficient as I am declaring now itself, but okay. Let's do DRC. If any errors, it should cut. Now this connection also I made this connection, I made this connection. output is ready. I made this connection, the ground was already ready. So let's give input, view all. Okay, I have to give inputs now. Zoom, give clock A, assign one more clock B, assign. So I am putting it here, just for you I am zooming it. I gave it here. The another one I given here as well. Okay, this is output. If I run, I should get output. Yes, I just need find. I can verify truth table, 0 and 0, output high, 1 and 0, output high, 0 and 1, output is high, 1 and 1, output is 0. So you can able to calculate the rise and fall of this as well. So similar to that of previous one. So at this point I just trying to end this video. I don't want to save it anymore. Let's stop and upload it.